Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 12th grade topic, Arithmetic series. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today, or even your own homework, you can always put in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 12th grade playlist, in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is only going to have 2 parts, so leave a like, smash subscribe, and let's get started. On this channel, we've covered arithmetic sequences and geometric sequences. Now we're going to be jumping into arithmetic series. Now, before we jump into that though, we want to talk about the difference between a sequence and a series. Now, you should know that a sequence at this point in time is just going to be a list of numbers. So if you have 1, 2, 4, 7, 9, it doesn't really matter. It's a list of numbers. Well, a series is going to be a sum of these numbers, right? So let's say you had a sequence of numbers. If you were to add them up instead, like this, you've now transformed this sequence into a series. So this is a sequence, and this is going to be a series. It's a series is a sum of these numbers that's in your sequence. So using that information, how do we get an arithmetic series? Well, the first thing you have to do is start with an arithmetic sequence. So let's say we have a sequence like this. You have 2, 4, 6, 8, 10. Is this an arithmetic sequence? Yes, we know that because there's a common difference of 2 between each one of these pairs of numbers. So as you are moving along in your sequence, you have a common difference of 2. You're going to be adding 2 to get to the next part of your sequence. This is an arithmetic sequence. Well, if you want to turn this into a series, an arithmetic series, you would then take the same sequence and add them up. And now you have an arithmetic series. So it's simply just taking your sequence and adding them. Instead of having your commas, you're going to have your addition signs. And there's a lot more similarities between a sequence and a series, because just like you have finite and infinite sequences, you can also have finite and infinite series. So let's say we have 2, 8, 16, 38, ... So this is a sequence, right? However, there's no end to this. This is going to be an infinite sequence. Well, if you were to take this same sequence, 2, 8, 38, ... and remove their commas, and then put your addition sign in there instead, keep adding as you keep going. Well, now you've turned this into an infinite series. If you were to chop it off right here at 38, this is now a finite sequence and a finite series. So series and sequences do have a lot in common, and because they look very similar, comma versus an addition sign, you can easily get confused. So just make sure you're understanding and you're looking at what you're working with. If you have commas, if you're a list of numbers, you're in a sequence. If you have a summation, if you're adding up all the numbers, you're not having a list, it's just adding up. A series is going to be adding up all your numbers. Make sure you're understanding what you're looking at. And assuming you have a finite series, there's also a formula that'll help you find what that sum actually is. Now, you can't really do that for an infinite series because it's just going to keep going on. Whether you're adding a positive number or a negative number, you're just going to get much, much, much bigger or much, much, much smaller. And it's going to happen at a fixed rate. So it doesn't matter if you're constantly increasing or constantly decreasing. No matter how small your common difference is for your sequence, which results in a common difference for your series, you're still going to be going to infinity or negative infinity. But if you have a finite series, there's going to be a definite answer when you're adding up the entire thing, or even just part of it. No matter how much of this you add up, because it's finite, you'll always have an answer, a sum, as a result. So let's say we have this arithmetic series here. Now, we can prove this is an arithmetic series because we would have some common difference that's fixed. Some common difference between each of your terms that's fixed, and you're summing all this up, which makes it a series instead of a sequence. However, that's not going to be necessary for this formula. It doesn't matter what your common difference is, because this formula doesn't depend on that. The formula when you're adding up this series is going to simply be whatever your n is over 2 times your first term, a sub 1, plus your last term, a sub n. So as long as you have a finite series, you have a definite endpoint for your series, you can use this formula to find out what that sum is when you add up everything here. And you can also use this to add up partial sums in here. So let's say you want to go, instead of all the way to n, you want to go to n minus 1 or n minus 2 or even a sub 3. It doesn't really matter. You can use this as long as it's a finite series. We'll talk more about using this formula in my next video, so make sure you come back. But for now, let's jump into a few examples to make sure we can identify our series versus our sequences. So in these examples, we want to identify what we have. Do we have a series? Do we have a sequence? Is it finite or is it infinite? And if it is a series or a sequence, is it arithmetic? Because that's what we're covering in today's video. So let's jump into our first one. What do we have for number 1? We have 1, -3, -5, -8, yada, yada, yada. What is this? Is it a series or a sequence? First off, well, this is going to be a sequence. Now, because we know it's a sequence, is it an arithmetic sequence? No, because the common difference between these is not constant. This is going to have a -4 difference. Well, this only has a -2. You don't even have to check anything else. Now, is it finite or infinite? Well, this is going to be infinite because it keeps going. So we have an infinite sequence here, but it's not necessarily an arithmetic sequence. How about number 2? What do we have here? Is it a series or is it a sequence? Well, this one is going to be a series. And we know that because we're adding. Now, is it arithmetic? Yes, because there's a common difference between each of the terms. You see, from 5 to 10, you're going up by 5. From 10 to 15, by 5. From 15 to 20, by 5. So this is indeed an arithmetic series. Is it finite or infinite? Well, because you're not continuing here, this is definitely going to be finite. So this is a finite arithmetic series. How about this one here? Is this going to be a series or a sequence? Well, this is definitely going to be a series because we're adding everything up. Is it arithmetic? Well, it's very close to being arithmetic because here you have a common difference of -4, -4, -4. But when you get here, you see there's a common difference of -5. So because the common difference is not actually so common, then we are not going to have an arithmetic series here. This is just going to be a series, a regular series, because that last difference throws us off. So if we were to have this, this is going to be a regular series, but is it finite or infinite? Well, because it's not continuing, we know that this is definitely going to be a finite series. Let's look at 3 more. When we look at number 4, what do we have? A series or a sequence? Well, because you have summing happening here, this is definitely going to be a series. Now, is it going to be an arithmetic series or a regular series? Well, this is definitely going to be arithmetic because we have a common difference of 1. However, is it finite or infinite? Well, considering we're keeping this sequence or series going, this is definitely going to be an infinite series. You're going to keep it going. There's no end here. Keep it going, infinite series. How about number 5? We have 4, 16, 64, 256. What is this? Is it going to be a series or a sequence? Well, because this is not a list of numbers, but a sum of numbers, we once again are going to have a series. However, is it arithmetic? No, not quite. This is not arithmetic, but this is a special type of series that we'll talk about in another video as well. But I'll leave that as a blank right now. Is it infinite or is it finite? Well, this is definitely going to be infinite because we're keeping this going. So we have an infinite series that's a little special. We'll tackle that once again in another video. Make sure you come back and you'll see exactly what this is. How about number 6, our last one for today? Is this going to be a series or a sequence? Well, notice we have a list of numbers now. There's no pluses. So this has to be a sequence. This is going to give us our sequence. Is it arithmetic? Not quite. Notice that you have a difference of 3 here, but you have a difference of 5 here, and a difference of 2 here. It's changing. Therefore, it's not going to be an arithmetic sequence. There's no common difference between all of these terms. So we're going to have a regular sequence. But is it finite or infinite? Well, it stops. 10 is its highest. So this is going to be a finite sequence. So I hope you were able to follow along with today's video and hope you now know the difference between your sequences and your series. And you don't get confused when you're trying to determine, do you have an arithmetic series or an arithmetic sequence? However, if you have any questions about what you saw today or even your own homework, you can always put in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I really hope this helped your homework. I'm looking forward to seeing you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Sempai.